Dear learners, the topic for discussion is mathematics as a way of life. In fact, this particular talk has been divided into two parts. In the first part, we will be looking into several applications of mathematics in real life situations. We shall do the same thing in the second part also, and the objective behind studying the applications is to sensitize the learners, the guardians about the fact that mathematics is a way of life. It is not a subject to be dreaded. I have experienced while talking to several guardians about the progress of their wards in the school, well, they will say that my son is not doing well in such and such subject, he may not be doing well in English, he may not be doing well in geography or any some such other subject. But when it comes to mathematics, well, they may say that he is not doing well in mathematics, but along with that, they normally add a comment, that is, he is afraid of mathematics. Why so? Why there should be a fear psychosis about mathematics? Mathematics, a subject not to be dreaded, and that is why I have chosen this topic, mathematics as a way of life. We will see that how it pervades our entire life in many forms, in several walks of our life. In fact, if you go for hard mathematics, it explains phenomena in the macrocosm, in the microcosm. So, I am not going to choose those kind of examples, but I will be choosing some examples which are directly related to real life situations and which can even be deciphered by people without knowing very high level mathematics. So, our objective is to sensitize the learners, the guardians about the fact that mathematics is a way of life, a subject not to be dreaded. Mathematics is the backbone of science, but more importantly, it governs the nature and in many ways our life. Now, why we say that mathematics is the backbone of science? Well, there are several phenomena in physics or in sciences which requires mathematics for its explanation. But here we will try to establish that several phenomena, several happenings in nature emerges from mathematics, and thereby mathematics should not be treated as a servant of science. Our tryst with mathematics begins with numbers. Let us treat numbers as facilitators, and in order to have a liking for mathematics, we need to develop an affinity towards numbers. In fact, handling numbers can be quite a fun. Now, let us remember the famous mathematician Srinivas Ramanujan. He was called the wizard of numbers. He had made very significant contribution in mathematics. Of course, this lecture does not have the scope to discuss all that, but as I said that taking cue from Srinivas Ramanujan, let us develop affinity towards numbers. One number is attributed to Srinivas Ramanujan, which is called the Ramanujan number. The story goes like this, that Ramanujan, when he was in UK and he was under the guidance of his mentor G. H. Hardy, and G. H. Hardy was mentoring him not only from the point of view of mathematics, but also from the point of view of the upkeep of his health. He was not keeping well there, and for a good part of the period of his stay, he was hospitalized, and Hardy would go to meet him at the hospital almost every day, and he would scold Ramanujan for not taking medicine in time, for not taking food properly, and so on and so forth. Now, one such day when Hardy had come to meet Srinivas Ramanujan, Ramanujan was quite cheerful. He was not unwell on that day, and but Hardy just came and sat silently beside Ramanujan's bed. Now, Ramanujan asked him that what happened? Every day when you come and scold me, but today I am cheerful, I am better. Why are you looking so much morose? Now, Hardy responded by saying that, well, today I came in a taxi and the number of the cab was very boring. It is a bad omen, O-M-E-N, omen. And why so? And he said that the number is 1729. But Ramanujan immediately reacted by saying that you are calling this as a bad omen. There cannot be a more exciting number than this. He said that there are very few numbers which can be expressed as the sum of two cubes in two different ways, and 1729 happens to be the least of them. It can be expressed as the sum of two cubes in two different ways, that is 1000 plus 729, that is 10 cube plus 9 cube, 1000 being equal to 10 into 10 into 10 and 729 being equal to 9 into 9 into 9. And it can also be expressed as 1728 plus 1, that is 12 into 12 into 12, that is 12 cube plus 1 into 1 into 1, that is 1 cube. There are several other properties of Ramanujan's number. We shall discuss about that in another program. But then see, handling numbers can be fun. Another Indian mathematician, Dattatreya Ramachandra Kaprekar from Maharashtra. Well, he was quite an exponent of recreational mathematics. Now, we shall now demonstrate the significance of Kaprekar's number. Like we said about Ramanujan's number 1729, there is a number attributed to Kaprekar. It is called Kaprekar's number or Kaprekar's constant. Well, I am not spelling out the number. Let the number emerge through a little bit of exercise which I am going to do now. Let us select a 4-digit number. Now, I have selected the number 9532, that is 9532, and all digits not being the same. Now, if we write this in descending order, then the number is 9532, and if we write that in ascending order, then the number becomes 2359. Now, when we subtract 2359 from 9532, the difference is 7173. So, we repeat the process. We write this in descending order, that is 7731, and then again in ascending order, that is 1377. The difference is 6354. Again, if we write that in descending order, it would be 6543, and ascending order 3456. The subtraction gives you 3087. And writing that in descending order gives you 8730 and ascending order gives you 0378. The difference is 8352. And again, writing that in descending order gives you 8532. Ascending order it gives you 2358. The difference is 6174. And now comes the climax. 6174, if written in descending order, it is 7641, and then in ascending order it becomes 1467. The difference is 6174. So, you get the number 6174 again, and so if you repeat the process, you will only get back the number 6174, which is called the Kaprekar's constant. Let us now take a 3-digit number, and of course, all the 3 digits not same. I have taken 123. Writing that in descending order gives you 321, ascending order it is indeed 123, the difference is 198. Writing that in descending order gives you 981, minus it in ascending order, that is 189 gives you 792. Writing that in descending order gives you 972 and ascending order it gives you 279. The difference is 693. This again in descending order gives you 963 and ascending order 369. So, the difference is 594. This written in descending order gives you 954 and ascending order gives you 459. The difference is 495. So, if you do the same thing with 495, well, the previous steps will get repeated, that is 495 written in descending order would be 954, ascending order it would be 459 and again you get back 495. So, 495 is the 3 digit analog of Capricor's constant. Capricor's constant is 6174. It happens for a 4 digit number only, but we also saw that it has a 3 digit equivalent, that is 495. We have clarified it through two examples, one of 4 digit number that was 9532 and the other was 3 digit number that was 123, and we expect that you will try it out for several other 4 digit and 3 digit numbers to satisfy yourself. So, I am trying to establish that handling numbers can be fun. We have done that with Ramanujan's number, we have done that with Capricor's number. So, let us also do this exercise of remembering some phone numbers. I know that you are in the habit of keeping the phone numbers in the memory of your cell phone, that is fine, but then let us also make some attempt to remember numbers, that can be quite a fun. I have chosen 4 numbers. First of that is of course a landline number 8 digited 29534274. Now, for remembering this number, let me tell you that this happens to be the number of an officer at an institution and the exchange number of that institution is 2953. So, 2953 is common to all the landline numbers in that institution and so you do not have to take much of an effort to remember 2953. So, the problem reduces to remembering the last 4 numbers 4274. Now, if you read this as a date, it becomes 4th February 1974, which happens to be the day on which Professor S.N. Bose passed away. So, if you remember Professor S.N. Bose and his passing away, then you remember 4274. That is how I remember this number 2953 4274. The next number is 98104371448. Now, for a student of science, it is very easy to remember 981. 981 centimeters per second square is the value of acceleration due to gravity. So, you forget about the first 3 digits. Next 2 digits are 04, which multiplied by 37, the then next 2 digit gives you 148, the remaining 3 digits. 37 into 4 is 148. So, that is how we remember the number 98104371448. The next number chosen by me is 9968317583. It is a number of one of my friends. Now, 9968 happens to be the first 4 digit of many numbers in Delhi. So, it is quite a common first 4 digit of the mobile numbers in Delhi and it is easy to remember. Now, you subtract 68 from 99, 9968 you subtract 68 from 99 and the value is 31. And then the next 2 numbers are 75 and 83. You remember Cricket World Cup. The first time it happened was in 1975 and the first time India lifted the cup was in 1983. So, that is how we can remember 75 and 83. Again, that is how I remember the number 9968317583. The next one is 98100247225. So, remembering 981 is with the help of the value of acceleration due to gravity. And I also believe that remembering the next 2 zeros will not be much difficult. Now comes the question of the last 5 digits 24725. Now, if you observe little carefully, you will find that 24, 7 and 25, they form a Pythagorean trio. They form a Pythagorean trio because 24 square plus 7 square is equal to 25 square. Here again you have a set of very interesting numbers which we call narcissistic numbers. Narcissistic numbers means the numbers which can see its reflection in its expression. Expressed in some form. Here of course, it is expressed in the form of addition of powers, and if it is a 3-digit number, it is a third power. If it is a 4-digit number, it is a fourth power. Now 153 is 1 plus 125 plus 27. 1 plus 125 is 126 plus 27 is 153. So 153 is 1 cube plus 5 cube plus 3 cube. Similarly, 370 is 3 cube plus 7 cube plus 0 cube. 371 is 3 cube plus 7 cube plus 1 cube. 407 is 4 cube plus 0 cube plus 7 cube. 4 cube is 4 into 4 into 4, 64. 0 cube is 0 into 0 into 0, 0, and 7 cube is 7 into 7 into 7, 343. The sum is indeed 407. 1634, it is a 4-digit narcissistic number. 1 to the power of 4 is 1. 6 to the power of 4 is 1296. 6 square is 36. 6 cube is 216, and 6 to the power of 4 is 216 into 6, that is 1296. So 1296 plus 1 is 1297. 3 to the power of 4 is 81. 3 to the power of 1 is 3, 3 square is 9, into 3 is 27, into 3 is 81, and 1297 plus 81 would be 1378, plus 4 to the power of 4. 4 to the power of 4, 4 to the power of 1 is 4, 4 square is 16, that into 4 is 64, and again that into 4 is 256, and 1378 plus 256 is indeed 1634. So handling numbers can really be a fun, and you can develop affinity with numbers by studying, analyzing, or making a collection that would be a very good recreation of many such numbers having peculiar properties. Now let us see some simple applications of mathematics in the real life situation. Now suppose you are traveling in a train in a 3-tier coach. You would like to know the position of the berth by reading the berth number. Now if you have seen a 3-tier coach, there are 8 berths: lower, middle, upper, again lower, middle, upper, then side lower, side upper. So the lower berths are number 1 and 4, middle berths are 2 and 5, upper berths are 3 and 6, side lower is 7 and the side upper is 8. And then you perform a problem of modulo 8. You take the berth number, divide that by 8. If the remainder is 1 or 4, it is a lower berth. If it is 2 or 5, it is a middle berth. If it is 3 or 6, it is an upper berth. If it is 7, then it is a side lower berth, and if it is exactly divisible by 8, that is if the remainder is 0, then it is a side upper berth. Suppose the berth number is 29, you divide it by 8, 8 into 3, 24, the remainder would be 5, so it would be a middle berth. So this is a very simple application, and you can learn so much of mathematics while traveling in a train. Now let me pose this question. We know Indian Standard Time, and we know that we are 5.5 hours ahead of the Greenwich Mean Time. Now why is Mirzapur chosen for determining Indian Standard Time? There is a clock tower at Mirzapur, and that is considered to be the standard for Indian Standard Time. Now there is an international law as per which the time difference between two nations should either be 0 or a multiple of 30 minutes. Like Bangladesh is ahead of us by 30 minutes. Pakistan is behind us by 30 minutes. Singapore is ahead of us by 2.5 hours. So it has to be a multiple of 30 minutes. It cannot be, say, 80 minutes or say 20 minutes. Now, when the earth rotates, it does so in 24 hours, that is 360-degree rotation in 24 hours or 1440 minutes, and 1440 divided by 360 is 4. So, per degree the rotation is 4 minutes. So, 1 degree is equivalent to 4 minutes. So, 30 minutes is equivalent to 30 divided by 4, that is 7.5 degree. So, the longitude of a place must be a multiple of 7.5 degree, and Mirzapur is indeed that. The longitude of Mirzapur is 82.58, which is very close to 82.5, and 82.5 is 11 into 7.5. 11 into 7 is 77, 11 into 0.5 is 5.5, 77 plus 5.5 is 82.5. So, Mirzapur is exactly 330 minutes, 11 into 30, 330 minutes or 5.5 hours ahead of Greenwich. So, the entire country is 5.5 hours ahead of Greenwich. Now, let us come to another interesting problem. What is common between these dates? 23rd January, which is birthday of Netaji Subhash Chandra Bose, 30th January the Martyrs Day, 1st May the May Day, 2nd October that is Gandhiji's birthday, and 25th December that is the Christmas Day. Of course, they are all important days, that is definitely a commonality, but there is some other commonality. Let us observe the first two dates, 23rd January and 30th January. The difference between them is just 7 days, which is equal to the length of a week. So, the day of 23rd January will be the same as the day of 30th January. Now, what happens with the remaining 3 days, and let us consider a year which is not a leap year, that is there are 28 days in the month of February. Now, number of days between 30th January and 30th April, I have chosen 30th April because it is the day prior to 1st of May, and both inclusive the number of days are 2 in January because 30th January and 31st January, 28 in February, 31 in March and 30 in April, and the total is 91, which is 13 into 7. It is an identity. Now, let us see the situation between 1st May and 1st October. Again, 1st October is being chosen because the next day is 2nd October. Now, the number of days between 1st May and 1st October are like this: 31 days in May, 30 days in June, 31 in July, 31 in August, 30 in September, and 1 day for 1st October. The total is 154, which is again exactly divisible by 7. Same is the situation between 2nd October and 24th December. The number of days in October now becomes 30 because we are counting from 2nd October to 31st October. 30 days in November, and 1st to 24th December are 24 days, which is 84, again a multiple of 7. So, the day of 1st May will coincide with that of 30th January, 2nd October will coincide with 1st May, 25th December will coincide with 2nd October, which means that all those 5 dates which I had shown earlier, they would be falling on the same day, provided it is not a leap year. And if it is a leap year, well, the 3 days, 1st May, 2nd October, 25th December will always fall on the same day. But if it is not a leap year, then all the 5 days will fall on a same day. Well, that is a commonality. If one of them is a Sunday, then each one of them is going to be a Sunday. Now, let me present 2 cases of same remainder. Again, these are identities. 365 is equal to 364 plus 1, 120 is equal to 119 plus 1, and this I have expressed as 365 equal to 52 into 7 plus 1, 120 equal to 17 into 7 plus 1. And again, 366 equal to 364 plus 2, 121 is equal to 119 plus 2. So, it is 52 into 7 plus 2, and 121 is 17 into 7 plus 2. Now, what does it signify? That is, if you go through a particular year, you gain by 1 day. Now, it normally happens that by the turn of the year, say in the month of January, you have still not received calendars and you are habituated in looking towards calendars. So, how do you manage? Now, what I say is that for 1st January to 30th of April, the number of days are 31 plus 28 plus 31, that is 90, plus 30 in April, that is 120. So, the next day is 1st of May. So, from 1st January to 1st of May also you go ahead by 1 day. So, the calendar of the month of May of the previous year will be the same as the calendar of the month of January of this year. So, at least for the month of January, you can manage by looking at the May calendar of the previous year. And the same happens if the initial year is a leap year, because we are going ahead by 2 days, and in between January to May again you are going ahead by 2 days, because February is in between, and that takes care of the one additional day, and that you get through this calculation 121 is equal to 17 into 7 plus 2. A few identities: 9 plus 15 equal to 24, 9 plus 16 equal to 25. Now, what does it signify? The first one may not be significant, but the second one again represents a Pythagorean trio, 3 square plus 4 square equal to 5 square. In the next one, again 49 plus 575 equal to 624 may not be significant, but the second one represents a Pythagorean trio, 7 square plus 24 square equal to 25 square. So, what Pythagoras had actually done. Now, this is one aspect of mathematics which I would like the learners to appreciate, that Pythagoras theorem may be a theorem in geometry, but with the help of that theorem, and then what you get by studying these numbers is that Pythagoras could relate geometry with numbers. So, the domain of geometry and the domain of numbers are not different. He could relate them, and there are umpteen number of such relations in nature which can be explained through mathematics. It would be interesting to mention at this stage that the particular date 5th December 2013, that is 5/12/13, was declared as the Pythagorean day, because 5 square plus 12 square equal to 25 plus 144, that is 169, equal to 13 square. 5, 12 and 13 form a Pythagorean trio, and the entire Manhattan was lit in the memory of Pythagoras on 5th of December 2013. Likewise, our Independence Day in the year 2017, that is 15/8/17, will also form a Pythagorean trio, because 15 square plus 8 square is equal to 17 square. We will talk more about that in our next program on Mathematics as a Way of Life, Part 2. There also we will be studying several such applications, and most interestingly we will be talking about application in sports. Thank you.